Good day everyone, and welcome to Ilan Technologies presentation on VLANs in Draytech Vigor Switches. This is part 2 of our 3-part webinar series covering VLANs in Draytech products. My name is Java and I'm a technical sales specialist at Draytech Australia and New Zealand. In today's session, we build up on what we learned in our previous webinar, where we looked at VLAN function in Draytech's Vigor switches. We'll look at separating voice and surveillance traffic from general traffic, along with a discussion about MAC-based VLANs which are used when end users have to physically move around, along with separating services on a switch port by using protocol VLAN, as well as discuss the management VLAN and its key benefits to manage the switch. If you have any queries during the video, just comment in the chat box that's on the right side of your screen and stick around at the end for a 5-minute Q&A. If you're watching this after the live premiere, please comment below the video or send us an email to sales@draytech.com.au. All of the features we'll discuss today are available in the Draytech Layer 2 Vigor switches shown on your screen, which includes the Vigor switch G2121 and P2121. These features are also available in Draytech's Layer 2 Plus Vigor switches, which include the Vigor switch G2280X, P2280X, G2540X, and P2540X. We'll be deep diving into Layer 2 Plus VLAN features in our next webinar. Let's start off today's session by looking at auto voice and surveillance VLANs. Auto voice VLAN and surveillance VLANs are specifically allocated for voice and surveillance traffic, which includes IP phones, IP cameras, and NVRs. Using these VLANs helps to simplify the network configuration by keeping the Vigor switch ports in default trunk mode. Devices can be plugged into these ports with minimal configuration required in the switch. The Vigor switch will automatically mark packets with QoS attributes and place devices in the correct VLAN. This helps to isolate VoIP and surveillance traffic from general data traffic, thereby improving data security. Data packets are prioritized using different Layer 2 802.1p class of service priority, or DSCP, that is Differentiated Services Code Point Priority, to improve VoIP quality. So, how do we identify the voice traffic and surveillance VLANs automatically? We use the OUI, which is the Organization Unique Identifier. This is based on the source MAC address in the data packet. IP phones and IP cameras will send data packets with a VLAN tag, voice, or surveillance. The Vigor switch will look up the OUI table, and if the source MAC address is matched, the packet will be classified as voice or surveillance traffic, remarked with COS value, and forwarded with higher priority. If no match is found, the data packet will be classified as general and forwarded with general priority. Another way to identify the voice VLAN is with LLDP MED, which is short for Link Layer Discovery Protocol Media Endpoint Discovery. Here the Vigor switch will automatically identify voice traffic. It sends LLDP MED discovery with voice VLAN, COS, and DSCP to neighboring devices. And when the endpoints receive this data, they will set up the voice VLAN tag and send the VoIP packets with the VLAN tag. The bigger switch will then forward this data packet with a high priority. I'll give you a brief demonstration of the Auto Voice VLAN. We will be using a VIGA 2926 LAC router shown at the bottom of this topology diagram. WAN 1 is used to simulate an IP phone which sends out data packets with a VLAN tag of 20. Also, WAN 2 is used to simulate an IP camera which sends out data packets with a VLAN tag of 30. We have port P5 of our main router configured as a trunk port, which is connected to the VIGA switch. In the VIGA switch, we will test port 5 or 6 for voice VLAN. First, we will go to the VIGA switch, and to set up the voice VLAN, we go to VLAN Management, Voice VLAN menu, and enable the voice VLAN. The voice VLAN is VID 20. Packets are remarked with a value of 6 and click Apply. Next, we set up the telephony OUI. We add the OUI address, which is the first 6 characters of the MAC address of the router. Then we enable the voice VLAN on ports 5 and 6. The COS will be added on all packets. Now we're going to configure the VIGA 2926 router to simulate an IP phone with VLAN tag of 20. In the router, we go to WAN General Setup menu. We enable the customer tag with a VLAN value of 20. In the switch ports, 5 to 8 are in default trunk settings with VID 1. Now, we'll connect WAN 1 of the router to port 6 in the VIGA switch, which is configured for voice VLAN detection. So port 6 is now connected, and we can see that it's now automatically tagged with VLAN 20. In the router, we can see that WAN 1 has obtained an IP address of 192.168.20.10, which is in VLAN 20. So this is how voice VLANs work. Next up, let's look at the MAC VLAN feature of VIGA switches. This is a very useful function when users need to move to different locations while still being part of their department VLAN. With MAC VLANs, the VLAN assignment is determined by the source MAC address in the data packet. This will work regardless of which port on the switch the device is connected to or which SSID they are using in a Wi-Fi network, and will work through multiple switches. An example of where this will be useful is for employees who need to move around the building with their laptops and still need to access their department resources irrespective of where they're connected. This diagram shows a typical scenario where the core switch is configured for MAC VLAN and all the other edge switches and access points are untagged. It allows mobile staff to move their PCs and IP phones anywhere in the building and always be within their department. We have the sales staff on VLAN 20, that's marked in red, and R&D staff on VLAN 30, that's shown in blue. All we need to do is to enter the MAC addresses of these devices in the core switch and assign to their respective VLANs. As long as all traffic can access the core switch, then it will be tagged by the core switch. This also means that there is no need to configure VLANs in the access points for different departments, thereby simplifying the Wi-Fi network installation. Let me give you a brief demonstration of how Mac VLANs work. Have a look at the network topology we will be using. The VIGA 2926 LAC down at the bottom will have its MAC address belong to VLAN 30, shown in blue, and the PC will be in VLAN 20, shown in red. If we swap connection on the VIGA switch, these devices will always be in the correct VLAN and obtain an IP address in the correct LAN subnet. We will start with the VIGA switch configuration. Ports 9 to 15 will need to be configured as hybrid ports. Since the end-user device is VLAN unaware, we need to enter the untagged VLANs 20 and 30 for the hybrid ports. Now go to Group Binding and select ports 9 to 15. Group ID 1 is tagged with VLAN 20, which has access to LAN 2. Group ID 2 is tagged with VLAN 30, which has access to LAN 3. Now go to Mac VLAN menu. We have set up Group ID 1 with the MAC address of the PC and Group ID 2 with the MAC address of the router. We will use the VIGA 2926 LAC as a VLAN unaware end user device. So we'll go to the router's WAN setup menu and remove any VLAN tag for WAN 1. To separate services on one port, we can use protocol VLANs. The Layer 2 header in the data packet is used to place devices into a VLAN. The switch ports will need to be set up as hybrid ports. In the VIGA switch, we have 3 different group IDs corresponding to each frame type. In the Group Binding menu, we select the switch ports and VLAN assignment. I've prepared a table that summarizes each of the VLAN type and its implementation. You can pause the video here to look at the details and perhaps even keep a screen grab for future reference. The last VLAN type in Layer 2 switches is the Management VLAN. Management VLAN is a separate VLAN on the switch to allow management by either the web or CLI. By default, it's set to VLAN 1, but can be changed to a different value. In a large network installation with many network devices, you can have a secure management VLAN for the entire network. So general data traffic is isolated from the management network. It is recommended to assign at least one port on the VIGA switch as the management port in case there is a problem accessing this switch over the network due to routing issues. A key benefit of using a management VLAN is improved network security, since users are prevented from making changes to network settings. For the management VLAN to be secure, it must only be used for controlling and managing the switch and should have restricted access. Now here's a look at the configuration menu for the management VLAN in the VIGA switch. You can select the PVID for the management VLAN and assign its IP address and default gateway as well as DNS settings. So to summarize, today we looked at voice and surveillance VLANs, along with MAC-based and protocol-based VLANs, as well as discuss the management VLAN and its key benefits to manage the switch. That's it for me, but please do stay tuned. Our staff will be answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about Dratec products, please check out our website at www.dratec.com.au or send us an email to sales@dratec.com.au or call us on 0298 388 99. Don't forget to like and subscribe below. And if you'd like a notification of new Premiere videos we're about to launch or anytime we put up a new video, please give the bell a click too. Thank you very much for your time today. I really appreciate it, and I do hope you found the session informative. Until we meet again, goodbye.